Okay, I'm going to slightly busk this one. We've got question 1B, and we've got my triangles 1, 2, 3, and then over the top there, where we have the reaction points here and here. We have 400 newtons each of these loads at the top of the joints. Quite an unusual problem, in that normally when you put loads, you wouldn't put a load at a reaction point, but this particular problem does have that, so it's a bit unusual in that sense. So first thing we're going to do is add up how much loads we're going to get, and then work out our reactions. So I'm going to have a reaction RAY going upwards there, and a reaction REY going up in that direction. The labeling convention for this framework we'll put over to this side here. Okay, have I got the right number? Is A, B, C, no, I don't have the right number, D, E, F, G, H, J. Okay, the load is perfectly symmetrical, the reactions are going to have symmetrical, so we're going to use symmetry. So we only need to know about the internal forces up to that point there, so we only need to go up to H, joint H. After that, then everything should start repeating. So the internal force in this member here should be the same as the internal force of this member here, and so on. Okay, so we've got 1, 2, 3, 4 joints to solve. We're going to apply symmetry, so 400 times by 5, that should give me a total load of 2000 newtons. So the reactions RAY plus REY needs to equal 2000. Apply symmetry, so we're going to say that the RAY equals the REY. Okay, so then therefore we can see that RAY equals 1000. Okay, the other thing, make a note of the geometry. Sometimes when you do truss problems, you use irrational numbers. So normally you would try to work with cos, so you'd avoid sines. Cos 0, we know that's going to give me a 1. Next angle of interest is cos 30, and so that's going to be what? Root 3 over 2. Cos 45, root 2 over 2. Cos 60 is a half, and then of course we have a cos 90, that'll be a 0. So Some people use the technique of using irrational numbers here as opposed to the causes. Because we're just going to do a one-off problem, we're going to use the cos values, so we won't be working in irrational numbers. But typically for framework problems at level 1 and 2 at university level, you probably would be working in irrational numbers. So we have 45 degrees here. You then want to look at your framework and work out the various angles that you need to be working with. So we've got 45 degrees here. Symmetry means that I think the setup tells us somewhere that's 45 degrees. So 45 degrees, that must mean that we're going to have a right angle there, 90 degrees at the bottom. So that's our problem set up. Now we're ready to do the method of joints. So the first method of joint we're going to do is at joint A. Okay. What you want to do here is you imagine that you're going to take your scissors and cut around joint A like this. Now we come to the labelling convention of the internal forces. The convention that I'm going to do is found in your OU. It's also the convention used in the majority of modern stress analysis books, where you define that your internal force is pointing away from the node, and if that value pointing away from the node is a positive, then it's in tension. So a positive internal force is tension, a negative internal force is compression. It's important that you keep the values so that you keep a track, therefore, on whether you're in tension or in compression. So each node, we imagine that there's a force pointing away, and that there's going to be an equal and opposite force inside that member, which is therefore obeying Newton's third law. There's an equal and opposite reaction because nothing's moving in that member, or at least we assume it's not. We assume it's not buckling or being stretched. So I've got a force pointing away, and these internal forces are always going to be balanced. Okay, these are internal forces, they're not external forces like your reactions and your loads. And we're going to need to go up to there and there. Now the trick is by taking this imaginary cut around this joint, you then cut through, you imagine that you cut through this member and you expose the internal force so that you can see it. That's what we imagine is happening. So when we work out what this force is going down this member and going along this member, when we get to this joint here, we then say that this force going in this direction will equal this force going in the opposite direction, so equal and opposite forces. The magnitude of those two forces has to be the same so that they balance. Some people use the notation that an internal force is just going to be given by the node numbers, the node lettering, so A and J. That's a sort of shorthand stress analysis approach. In the book they're using F subscript AJ, so I use that for you. So let's look at the first joint then. So the first joint, you want to draw another diagram where you've now cut through the joint, the members, and you've exposed those internal forces. You've defined them by default to be pointing away, and you're defining pointing away as to be in tension. If you go back to older stress analysis books, you might find that the definition is not exactly the same as that. So we're going to say that this is my joint A here. So you can see that we're going to have an A to B in this direction and an A to J. Most stress analysis books like to use the lower letter first. Okay, so we've got force AB going in this direction, force AJ going in this direction. Okay, I've got a load of 400 going in this, so this is my first external force, and I have a reaction force here of 1000 going up. So both of these are external forces, and you need to consider both of them. Overall, you can see that we're going to get 600 pointing upwards. So you might want to combine these two forces before you move on and do anything else. Right, we've got an angle of 45 degrees. We're going to work in not in irrational numbers, but in terms of causes, and use them like that. To avoid truncation errors, you can give two results, one involving what the cos and the angle is, and one what would be to, I don't know, say 3 or 5 significant figures. Okay, so I've got forces here, and my argument is, for the method of joints, that my forces must equal 0 if I resolve them in a certain direction. When you resolve forces in a particular direction, you need to consider really which way your unknown forces are pointing. We got one force pointing here left to right, one force pointing sort of left to right and downwards. So that means that the first resolve your forces, the first one you should do is resolve your forces pointing downwards. I'm going to go downwards because also it's a good practice really to decide to resolve your force in a direction where the basic unknown is, because that means that would be a positive value in your equation. So we're going to resolve downwards because it's so there's only one force going downwards, so that isolates just one force, you see. So when we add up our forces pointing downwards, they should all give us a 0 overall summation. This is 45 degrees. Put in any more geometry that you need, so I know that that's now 45, and try and work always in causes. So now we're going to swing through this force here to the downward vertical by 45 degrees, and you swing through an angle, and then you know that you need to apply cos. So we've got a downward FAJ cos 45, okay, and then we're going to have so that's going downwards, this is going upwards, which is opposite to the direction we're going to find to be positive, so minus 1000, and then I've got plus 400 going downwards. That equals 0. So let's rearrange that, and you can see I'm going to go FAJ cos 45, and then that's going to give me an overall minus 600, so that'll be a 600 there. So I'm going to write out two results. FAJ equals 600 divided by cos 45. The first result is the result that I'm going to use and substitute into any subsequent equations. And the next result I use, I'm working in newtons here, so the next result that I use is my final result to present to the reader. So I've got 600 divided by cos 45, and that's going to be 848, and I'll work to 5 sig fig, so 5 newtons, and I'll tell the reader that this is going to be in tension because it's positive. That's my definition, so it's in tension. Okay, now I will resolve forces going left to right, because this FA needs to be worked out. So we're going to resolve forces. They're going in the x direction, and we're going to point our x direction to be positive, left to right. Right, so we've got FAB. Try and write that one down first, because then we can always keep that on the left hand side. Next force, don't substitute this value in yet. Use the algebraic force. So we've got plus FAJ. We're going to swing through 45 degrees to get it pointing vertically, sorry, not vertically, horizontally. So cos 45, and these forces are both pointing vertically, so there's nothing happening there, so that equals 0. So rearrange this until you're happy before you substitute in what FAJ is. So FAB equals minus FAJ cos 45. And the value that we're going to substitute in is, we're not going to choose the final percentage result that we gave to the reader. We'll use our intermediate result here, so the 600 divided by cos 45. So you've got minus 600 divided by cos 45 times by cos 45. And now you see I get no truncation error. Minus 600. That's a result that I can use for either substituting in later or for the result presented to the reader. So minus 600 newtons. Because it's a negative, we say that's going to be in compression. Okay, so that's done our first joint, A. Now we've got to decide then which joint we're going to go to next. If I go to this joint here, I can see I've worked out what this internal force is, and I don't know that internal force, I don't know that internal force. So there's two internal forces I don't know. If I go to B, then there'll be this unknown internal force, that's 1, this unknown internal force, that's 2, this unknown internal force, that's 3. So if I go to B, there'll be 3 unknowns. If I go to J, there'll be 2 unknowns. Generally speaking, with method of joints, I can only go to a joint where there's 2 unknowns, so I have to go to J. A special case might be where if we're going to something, say in the middle, where you could then maybe apply rules of symmetry or something like that to your solution. Okay, so we're going to J, and we're going to cut through the members, and we're going to pick out these forces here going around J. So I'm going to have an internal force going off in this direction, one going in this direction, and then one going in this direction. There's no external forces being applied at this joint. So this is going to be my force AJ going off in that direction there, and I will use the notation convention of that we use the lower letter first, so BJ going in this direction, and F HJ going in that direction there. Okay, what do I need to know in terms of angles? Well, this is a right angle, so I know that's a 45 degrees to go from there to there, and 45 degrees, so that's another 45 degrees. The other one that I might want to know is that the 45 degrees go from there to there. So label up your angles, and when you resolve forces, try and swing through an angle that's acute. And so in this case we're going to swing through in this direction, and we know it's negative if we're looking at forces going in this direction. So now let's examine this joint J and say to ourselves, where are the unknowns pointing? Well, we've got an unknown pointing left to right, and another unknown pointing left to right. I've got only one unknown pointing upwards. So unlike so actually it's the same as before really. I want to resolve forces pointing upwards. Because the unknown force that I'm looking for is BJ and it's pointing upwards, I'm going to define that to be my positive upwards direction. So we're going to do it like that, okay? So the first force that I see is that I've got F AJ. I need to swing it through 45 degrees, and that would become cos 45, and then it'd be pointing vertically. And then FBJ, I need to swing that through 45 degrees, and then that would be pointing upwards. So FBJ cos 45 equals 0. So, well, at this point it's tempting to factorize the cos 45s, take them out. So this case I've now got BJ equals minus FAJ. I go back to my previous joint and look at what AJ is. So AJ is these two numbers here. So FBJ is going to be minus 600 divided by, let's try and get my paper straight, cos 45, and it's going to equal minus 6486.43 newtons. Now because it's now a negative, that means that this is going to be in compression. Alrighty. So the next force to work out is going to be this FHJ. That's pointing off left to right, so I'll define that to be my positive direction. Sum up the forces for the x component, and now what we got. Now going through the joint this time, I've got FAJ pointing in this direction. I'm taking this to be positive, so I want to swing this through to the horizontal and make this a negative. So I have minus FAJ cos 45. Notice I work in with the algebra of my force diagram, and I substitute values at the end when I'm happy with my equation. This one here needs to swing through 45 and then it will be pointing left to right. So plus FBJ cos 45, and this one here is going left to right, so that's just going to be plus FHJ equals 0. Okay, so this is the value that we're looking for, so we'll keep it on the left hand side. FHJ, that then equals FAJ cos 45, take away FBJ cos 45. Now we are ready to go back and substitute in our values for AJ and BJ. So AJ, we need to go back to the previous joint, so that's going to be 600 divided by cos 45. So I have 600 divided by cos 45 times by cos 45. This one here is going to be a minus, so we have minus 600. Good to use brackets when we're substituting minus values. Cos 45. So you have a minus minus, so this is going to end up as a plus, times by cos 45. So I can see my cos 45s are all going to cancel, and we end up with 600 plus 600, so that will be 1200 newtons. Okay, so that would be that joint there. So how are we doing? So we've done joint, so this is our joint J, isn't it? So we've done joint J. Previously we've done joint A. Let's go back to our diagram, and how much more do we need to do? So we need to get to do joint B, and we need to then finish joint H. Okay, so let's go to joint B next then. So we've got a force from above of 400. The internal force is playing out in all these directions. Put a vertical line in here, and we know that we have 45 degrees to get to the vertical, and therefore it's going to be 45 degrees to get to these horizontals. Let's label these up. So I've got force AB, force BJ, and then force BH, and force BC. So the first thing I notice is that I know this force, I know that force, the internal forces. I don't know this one here going downwards and to the left stroke right, and I don't know this force here going horizontally. So there's only one force going downwards, so I'm going to resolve forces downwards. So let's resolve forces downwards, and that will pick up the unknown force here that we're looking for. So F, BH, need to swing that for 45 degrees, cos 45. Then we're going to take this force here, need to swing this one through. So it's going to be F, BJ, cos 45. And then the final force we've got going downwards is the 400 load going straight downwards, plus 400 equals 0. Okay, so let's rewrite this for FBH. We're going to divide through by the 45 as well, so we're going to have F minus 400 divided by cos 45, and then I'm going to have minus FBJ, okay, divided by 45, so that will cancel. Right, let's substitute in my value for BJ, so minus 400 cos 45. Go back to my joint, I suppose it's going to be joint J, isn't it? So we're looking for the BJ, so here we go, we've got minus 600 cos 45. So minus 600 cos 45. So you can see you've got common 45, cos 45 is on the bottom there. Overall that's going to give me 200 over cos 45. Okay, so I will leave that as a temporary result, which I will use for my later substitutions, and then put that into my calculator and get 282.84 newtons. Because it's a positive number, that's going to be in tension. Right, now let's resolve the forces in the x direction. We're looking for BC force here, so I'm going to point my arrow left to right. Sum up my forces. Okay, so what we got then? We've got FBC going off in that direction. We've got this FBH, which I need to swing through 45 to get to pointing in that direction. So FBH cos 45. Now these forces are going to be pointing in the opposite direction to the direction I've defined my coordinate system in. So I'm going to have minus FAB, and I'm going to have minus FBJ cos 45 equals 0. There's nothing else there in the horizontal plane. So that's going to give me FBC is what I'm looking for. Let's take these negative numbers over first, so they become positive. FAB plus FBJ cos 45. And now let's take the last one, minus FBH cos 45. And now we want to go back and substitute our values in. So FBH, okay, so that's up here, so that's that one there. Let's substitute that one in. So we have minus 200 cos 45 times by cos 45. Let's look for BJ. So that'd be, going back to the J joint. So BJ is, that's minus 600 divided by cos 45. So we're going to have plus minus 600 divided by cos 45 times by cos 45. And now FAB, so I'm going to have to go all the way back to joint A, and what we got here, so we've got what we're looking for, FAB, yeah, here we go. So we've got minus 600 okay, so that'll be minus 600. Okay, right, so I think that's everything. So we've got now cos 45, that and that cancels, that and that cancels. Well, what do we end up with? All these are minuses, so minus 600, minus another 600, minus 200 there. So minus 1,400 newtons, so that's going to be in compression. Okay, so this is going to, that's for joint B, done there. Okay. Right, so last one, we need to go for this thing here. So that joint there, so that's a H joint. We know that force, and we'll be looking for this force going off in this direction and this force going off in this direction. All these other forces we're going to just say that they repeat with symmetry. Alright, so I'm on joint H. And so what we got here, so we've only got internal forces, got a joint H down there, got these all splaying off in these directions. That's 45 degrees, 45 degrees, 45 degrees, 45 degrees all the way around. Okay, so let's label these up. So we've got force HJ, force BH, force CH, and force GH. Okay. The forces I know is this force here and this force here. So I've got a force going off vertically and also horizontally. I've got a force going off here horizontally. So I'm going to resolve forces first of all in the vertical direction going upwards. So we're going to go upwards. And what we got? So the force we're looking for is the FCH. FCH, I need to swing that through 45 degrees, so cos 45. Then we've got FBH, need to swing that through 45 degrees, so FBH cos 45. What else have I got? Nothing else actually, is there? So that equals 0. This is quite straightforward, this one, because that and that are going to cancel. So FCH is just going to be minus FBH. So FBH, I think we can go back to joint B and we should find it somewhere. So there we go, we've got FBH is 200 divided by cos 45, which is minus 28284.4 newtons, and this one will be in compression. Okay, and now let's find our final one. So we're going to go off in this direction, left to right. So F, we're going to sum up our x forces going off in that direction there. So that gives me FGH plus FCH. I need to swing through 45 cos 45. This one here will be going, I need to swing through 45 but going in the negative direction, so minus FBH cos 45 minus HJ. Okay, right, so we're looking for FGH. Let's rearrange this. So we've got FHJ plus FBH cos 45. Let's bring in that and that over to the right hand side, minus FCH cos 45. Right, so one of these will be from above. So yeah, we've got this CH term there. So minus 200 cos 45 times by cos 45. So that and that's going to cancel. So watch out, I've got a minus minus, a plus there. FBH, I think I probably need to go back to joint B. So that's going to be 200 divided by cos 45. So we're going to have plus 200 cos 45 times by cos 45. So that and that will cancel. So I've got 200 plus 200 so far. And now FHJ. So I probably need to go back to the J joint. So FHJ is 1200. So we've got 1200. So that's going to give me 1600 newtons. And I should have said that's going to be in tension. Right, so we could then draw up our values that we've got, which are going to be in tension, which are going to be in compression. So let's do this. So we got 1, 2, 3, 4. A, B, C, D, E, F, G, H, J, and so I'm going to do black for tension and red compression. And now look back on my values, see what we've got. So F, G, H. Okay, so F, G, H, that's tension. So that's a 1600 there. F, C, H. I'll round this up to a Newton. So CH, that's this one going off in this direction. So that's 283. Okay. Alright, now let's go back. Let's look at this joint. So that's the J. So HJ. I should have said that was in tension. So HJ is in tension, so that's 1200 there. And this one here, so we're going to make that 849. So minus 849 BJ. So minus 849 going off in that direction there. So that's getting compressed. What else? What other joints we've got? So we've got the B joint here. So in tension, I've got B, H. So 283 BH. So this one coming down here, 283, and we've got BC in compression of minus 1400. Alrighty, and then our final joint here. So 849 in tension AJ. 849, that's in tension, and then the AB member is in compression and minus 600. Okay, and then we can just use symmetry reflecting those values. So that's our final result. Sorry about the flicker there, but yeah, so that's it really. Took about an hour.